This is Muthuramya Research Scholar, EC Department, NITPY. I welcome you all for the third session of third day of 5-day national workshop on advancement in antenna engineering using artificial intelligence. It is the second part of.
Yeah, go ahead. Right.
Fourth person, Dr. A. Prakasa Rao sir here. I want to introduce Dr. A. Prakasa Rao sir again. Dr. A. Prakasa Rao sir obtained his bachelor degree in ECE from Nagarjuna University, Andhra Pradesh, and master's degree in ECE from Pondicherry Engineering College, India. And he obtained his doctoral degree from National Institute of Technology, Warangal, India. He has more than 22 years of experience in teaching at various organizations. Currently, he is serving as associate professor in the Department of ECE at National Institute of Technology, Warangal, India. It's about 20 papers are at his credit in international and national journals and conferences. His area of interest includes signal processing, smart antenna systems, and optimization techniques. He is a life member of ISTE and also a member of IEEE. There are 40 UGPG projects completed under his guidance, and currently he is guiding 2 research scholars. He has organized and conducted 6 faculty development programs and served for many administrative responsibilities in institute and department level. He has been an invited speaker for several programs at different universities and engineering colleges. He has attended 1-month training at Signal Processing Laboratory, University of Southern California, Los Angeles, USA. He has been a reviewer of a few SCI journals. We welcome you, sir. We welcome you again, sir.
Thank you, madam.
Yes, sir.
Thank you.
Now I request sir to take over the session. Thank you.
Okay. Thank you, madam. Thank you. Thank you. Good afternoon to all. Once again, I'm very happy to see you through online for attending such workshops. Last class we have seen optimization techniques. What do you mean by optimization? Using optimization techniques, we are going to get the optimal results in a efficient manner and effectively. We are going to use frequently these techniques in a number of fields, engineering and non-engineering sectors. And we are going to use optimization techniques, especially in antenna design and antenna beamforming areas. Then we have seen introduction and motivation, why you are going for this. So with the help of optimization technique, we are trying to place the main beam or directional beam towards the desired user direction, and we are, at the same time we are trying to minimize the other side lobes as much as possible. And not only that, we are trying to place a null in unwanted signal direction. That is our goal. So we are trying to minimize interference and noise levels at user place. So to achieve that desired radiation pattern, we are trying to use the optimization techniques using different algorithms. We have seen a list of optimization techniques, heuristic algorithms, and from that we made a conclusions. If you observe the nature very closely and carefully, we will get n number of ideas, and from that we can get a efficient algorithms or solutions for existing problems. So we have to motivate to our students to observe their surroundings, and they have to watch very carefully the nature, and from that they will get the n number of solutions. So today we are very comfortable. Our lifestyle is completely changed due to satellite mobile communication and all. This was started this mission during 1965, but the idea was given Arthur C. Clarke in 1945. After his idea, after 20 years later, the people are verified and developed the mathematical techniques and verified technically. Then they started the working towards in this direction. But the idea was initiated in 1945. And before that, in the 60th century itself, Kepler, as a German scientist, the famous astronomer, he has observed the space very closely and very effectively and very careful observation, the movement of the stars in the sky. At the time, they don't have the sophisticated equipments and all, and they struggle a lot throughout their lifetime, and they never lose the interest. And finally, they developed and they proposed the three statements that I'm not going to touch right now. And later on, Newton has started, after 50 years, he has developed mathematical proof for that statements. At that time, people are laughed. Is it possible or not? Then, now we are comfortable. So what I'm going to say here is, if you observe the nature and if you are going to watch very closely, and keen observation is important, when you observe that, then we'll get it ideas, n number of ideas, and those ideas are very, very valid one. There is no doubt in that. But the way you are going to look into the problem is the matters. If you are going to observe very closely, detailed, at the minute level, and very closely, carefully, then we will get the excellent solutions for the problems. But actually, the solution is inbuilt in the problem. The solution is inbuilt in the problem. We are just seeing and they are observed. Careful observation. There is a difference between us and them. That is why we are normal persons and they are great persons. But both are same. The only difference is that. So if you motivate to the boy, and the boy will have that qualities, and he will identify his internal qualities. So as a teacher, we have to explore his qualities. So you have to support, you have to encourage. Apart from the taking the classes, this is one we have to do that. Then we'll be in the top in the worldwide universities. But today we are lagging. But decades back, our institutions, Nalanda and other things, Takshashila, are very famous. Throughout the world, we are the origin for the technology. And today we are in the backside because of many reasons. I'm not going to address that. So the thing is, we should not take the class in a commercial way, the business-oriented way. Once if the education is turned into as a commercially, then we are lagging behind that. So we have to utilize the technology, and you have to motivate the students to observe very closely, and they can find out so many things. So I hope that you understand my intention of the taking the class. So that we made a conclusion from that list. Then once you got the observations, you can develop the new algorithm, and you can test it with the test functions using existing one. And from that you can compare whether your algorithm is good or not and all. Then later on, we are seeing the number game. With the help of the number game, we are seeing the LMS algorithm, how it is. So in the LMS algorithm, least mean square algorithm, we are trying to minimize error function to 0. So to make it that, the weight vector is going to be updated iteration by iteration. The next weight depends on the previous weight plus step size and error function. So if you do properly, then next weight is going to be updated, and based on that, by iteration, after a few iterations, we will get a optimal results. That we have seen the in LMS algorithm. Then we have seen the smart antenna beamformers and compared with omnidirectionals. Using beamforming, we can get the high gain, and due to that, signal capacity is going to be improved, the noise can be minimized. Then it can be used in SDMA, space division multiple access technique. Then with the direct contact, the battery power can be saved, and it can be used in radar Not only that, in a mobile communication and so on. Then we can minimize the, or you can have a control on delay, uh, phase delay by reducing the multipath signals. Then we can enhance the GP allocations by improving the directional finding and direction of arrival estimation. And by controlling side lobes and nulls by placement of the proper way nulls in the radiation pattern, and we can control the interference some extent, and that will lead the signal to be the quality of the signal is going to be improved. So these are the some important features when you are going to compare with the omnidirectional. We should not say always beamformings are excellent based on the application. That you have to say. We see normally when you are taking class, this is good, that is bad, that is not correct. For time being, when comparison, we can say, but it has own merits and demerits. So when you want to radiate the signal in all the directions, I have to go for omnidirectional only. For searching purpose, omnidirectional is excellent. So to radiate the signal in all the directions for all India radio purpose, then omnidirectional is excellent. For FM, omnidirectional is excellent. So based on the application. So you should not say that omnidirectional is wasted and beamforming is good, or beamforming is worst, omnidirectional is good. Not like that. So you should not make a concrete statements to the boy. You have to address, and based on the application, he has to pick up. So like that, we have to motivate, and the boy should understand the difference between that. For time being, these are the differences. Then the beamforming can be applied in n number of fields. We are seeing radar, communication, military applications, in a biomedical, and so on. Oil exploration, and like that, it can be used. Then we have seen the 5G and beyond 5G concepts, because today we know that the importance of the online classes and importance of the online business and online all these things. Nowadays, everything is online video conferencing and all these things, charting and all. So when you are going to use so many services and features simultaneously, a lot of bandwidth is required, and speed also is going to be increases tremendously. If you are not going to provide sufficient bandwidth and speed, then there is no meaning of that. So the quality is also important. You are offered something to 4 families, and that is not at all edible or not at all useful. Then what is the meaning of offering? It's meaningless. So, so whenever if you are going to offer something, that should be acceptable range, above the threshold level. So you are provided the connection from point to point, but a lot of noise and all, and it takes much time, and latency is very high, then useless. So you have to address the significance of that. So these things are to be solved by when you go for the next generation. So using 5G, and we can get the high speed, large bandwidth, good quality of the signal, and coverage is up to 100%, and low latency is possible. So this is another important feature, low latency. Especially these are going to be used in driverless cars and all, and it can be used in battery life can be improved using 5G and beyond 5G, because IoTs are especially the very compact and small units. So frequently we need to recharge, but that is not good. So we have to find a direct path, and so that is minimum energy is sufficient, so that the battery life can be improved. So these are the certain features we have seen in the last class. Then we have seen how to apply LMS algorithm in beamforming, and when n is equal to 21 elements, n is equal to 51, and how to control and all. So whenever if you're going to design any algorithm, you have to concentrate robustness, then convergence, then rate of convergence, then what is the other one? Cost function. These are the important parameters one has to look into that. So already I discussed it briefly. I'm explaining once again. So the robustness means once you designed, it has to work at any environment. So like that, you have to design the system. Then convergence means the output should be stable, it should not be deviated much. Then rate of convergence, we got the convergence, but how fast it is, then computational load, how many additions, multiplications, or divisions or subtraction, whatever the thing, how many XOR gates you are using, OR gates, all these things. So when you go to the down level, the circuit complexity is also very important, and number of iterations and number of operations are increases, then the power level also demands more. So you have to be very careful, you have to minimize the operations. Then one has to concentrate how to define the cost function. This is another primary thing. So you have to consider the side lobes, nulls, main beam, bandwidth, all other parameters. So when you consider all these things, then your algorithm is going to be excellent, and based on that you will get a better results. And immediately the app, once if you develop thing, and you will get a reasonable results, and those results are going to be accepted by easily by the reviewers, and acceptance rate will be good. So like that you have to motivate. Then we'll see the today's section, continuation of the last class. Just now we are discussing the brief introduction and what we have discussed in the last class. So now the genetic algorithm, it is a heuristic search algorithm. It provides efficient and effective technique for optimization purpose. So these are the steps involved: chromosome construction, initialization, selection, crossover, mutation, and termination. Then construction is very important. You have to be very careful. Then generate the initial population, and once it is initial population is available readily, then you have to evaluate with the help of the fitness function, and if they are performing well based on the ranking, you have to pass to the next iteration. If they are not performing good, and based on the selection criteria, you have to discard, and those who are satisfy the minimum criteria, and allow them to go to the next iteration. Before going to next iteration, one has to concentrate and apply the operations, crossover operation and mutation operation, to modify further, and then we'll develop the new generation. The previous one is the old generation. Once we do this, and the new generation will come, and again you have to test it, again you have to evaluate with the help of the fitness function. Once if it is good, you have to stop the algorithm, otherwise again you have to repeat it. And even if you are going to stop the algorithm, you have to
Participants, please wait for a few minutes.
Now it is okay. Anyone can respond so that I will
Yes,
continue.
sir.
Yeah,
Yes,
good.
sir.
Right,
Please
right.
share your presentation,
Suddenly
sir.
it is gone. Okay, doesn't.
Oh,
So no, don't worry.
okay,
Now
sir.
we'll continue the where you are. From that point, I will start. Yeah. So now we can see that Rosenberg function, and we need to find these
Sir,
values. So for that,
sir, your
initially,
presentation is not visible, sir.
what,
Sorry for
madam?
the interruption. Your presentation is not visible,
Not
sir.
visible. So I have to
Yes,
check
sir.
once again. Wait, just a minute.
Okay.
Whether I'm giving a, slide share or not, I have to check. Just a minute. Present now. Screen. Then okay. Now it is coming.
Ah, yes, sir.
If it is visible, please
Uh,
respond by in the chat
yes,
box or okay now. Now it is okay.
yes, sir. Yes, sir. Your
Now
screen
it is
is
okay.
visible. Yes, sir.
Right, right. Good, good. So these are the problems because we are not using the Wi-Fi networking and all. So we are not in 5G and all. These are the other reasons. Okay. So now you can see that the Rosenberg function. Then we have to find the minimum value. So global minimum. So assume that your x1 is varying from -10 to +10, and x2 is varying from +6 to -6. Where is your minimum value? So here 20 points, and here it is 12. So 12 into 20. So 240 points we have to test it, and after few iterations we will be fed up, and assume that if the d is 10 and the 10 dimensional, then it is very very complex. So one has to use some techniques. So when you are going to use the optimization technique, the initial population is spreaded like this randomly. It is in a random. So after few iterations, say all these particles, the possible solutions, these are all our possible solutions. After few iterations, it is trying to converge it to the desired location. So this is the intermediate result. So at the end, so all these particles are converged to this point. All will be converged to this point. So here we got it, global minimum is equal to 0 at x is equal to all ones. So if it is d is equal to 10 dimensional Rosenberg, then we have so many combinations and it takes much time. So to avoid that, and one has to use the optimization technique. Then genetic algorithm crossover. Before crossover operation, your chromosome value is in a decimal is 175, another one is 240. When you're trying to represent in a binary form, you will get like this. We can do in a either binary or in a decimal form. I represented both are here. So here, before crossover, these are the two values, and after crossover, you can see that the last 4 bits and each chromosome mutually exchanged. So the first 4 ones are replaced by all zeros, and the second chromosome, all zeros are replaced with all ones. Now after crossover, 175 becomes 160, and 240 is turned into 255. Assume that we don't have 160 and 255. So these are the new values. These are the old generation values, and after crossover we got the new generation. So how do you know that these are correct or it is good for you or not? So to validate, again you have to test the cost function. So with the help of the cost function, with the help of the fitness or objective function, you have to find whether these chromosomes are giving better results or not. Once if it is giving, you have to accept. Or if it is not, compared to before crossover, it is giving reasonably good, but you are not happy. Then you have to go for a mutation. Assume that in another case, before mutation, it is I have taken 170 in the binary form. 170 is 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 170
Sir, your voice is not audible, sir.
Hello, sir.
Oh my God. Now is it audible? Now is it audible? Say loudly.
Yes, sir. Yes, sir.
Yes. Then I will start. So whenever
Thank
you
you,
have a
sir.
problem, please tell me, because I don't know whether you are following or not. So immediately you have to respond so that I can, because it is offline, so very difficult to monitor. So
Yes,
now
sir. Yes,
okay.
sir. We will tell,
So
sir.
we'll go back to
It
the
is okay,
previous
sir.
slides. So I'll go back to the previous slides. Don't worry. Quickly will come. So this is anyway last class we have discussed, and initial population. We can see that here all the particles are randomly spreaded in the initial phase, and after few iterations your possible solutions are going to be converged to the desired value. So here we can see that we'll get it global minimum is 0 at your variables are all ones. So this is possible. After few iterations, you will get the results. So if you want to do manually, so many iterations are required, and we don't know how much time it takes and all. So as the dimensions are increases, then crossover operation. Before crossover, it is 175 and 175 and 240 are considered, and these are the binary notation. And look at here, after crossover, the 175 is turned to 160, and 240 is going to be modified as 255. In the binary form, you can notice that all 4 ones are modified as ones, and all zeros are mapped with all ones, so that the value is going to be changed. So before applying crossover, we have these 2 chromosomes, or we can say population, and it is modified as 160 and 255. If these two are good, and if it is giving a reasonably response, then you can stop it. Otherwise you have to modify again for the next iteration. Similarly, you can go for the mutation operation. Sometimes you are very closer to the response, but you need to fine tune. Then we can modify either 1 bit or 2 bits or any location. Right now I have taken 1 bit modification, extreme right. So this 0 is turned to as a 1. So initially it is 170 before operation, after operation 171. Need not be 1 bit. You can change 2 bits or any locations also. Based on the application, we can do that. Then the specifications, we can see the hybridization and standard LMS. And these are the specifications: 20 elements, 0.5 lambda, desired direction is 150, unwanted signals are at 2 different locations, 50 and 100. Now you can see that these are the responses for standard LMS and hybridization technique. So when you look at these two radiation patterns, it's very difficult to find the difference among them. And we can't get the how much time is taken by this algorithm and how it is converged. All these details are missed here. It is not possible. So we have to concentrate on convergence plots. Now you can see that convergence plot using a standard LMS algorithm. We have a convergence around at 20 iterations, but that is due to local structured local minimum problem. Then again, after a few iterations, it is coming out. Then again, it is going to be converged. So yesterday I gave one example. Once again, I'm going to repeat the significance of this. What do you mean by convergence? Again, it is. So you are conducted one test and all are got a good marks. Is a fine. Then based on that, we can't decide all are good students. If you conduct several tests, then you can see that out of 100, hardly 10-15 students they are performing throughout all the tests. They are going to do that. So if when you observe all the responses, you came to know that they are performing constantly. The others, it is random. One test is good, another test 0, another test maybe high, like that. So that is the meaning of that convergence. So whether it is converged in a stable way or not. So here it is good, but after few iterations, the algorithm is not performing well, and again after 60 onwards, the reasonably we are getting a good results. But whereas using hybridization, due to hybridization, we can see that performance is going to be improved after 55 iterations is almost constant, and you got the flat response. And in the middle also, the convergence deviation is or the error performance also drastically is controlled, the difference. Then you can see that the magnitude response, how the weights are going to be updated. In a standard LMS algorithm, the weights are going to be updated in a random fashion, whereas in hybridization, the weight is going to be updated very smoothly. See here it is a highly random, and here it is somewhat compared to this, smooth transition is going to be takes. Here also is random, but it is a smooth, and here it is highly random. Then we can tabulate all the readings, and from that you can understand LMS, RLS, GA, and hybridization. From that you can understand which one is giving better results. Then based on the previous slides, we can list out all these high points to be highlighted. Finally, the interference is going to be reduced, and signal to noise ratio is going to be improved, and deep nulls are going to be generated, and it is placed in unwanted directions. Then you have to see the D, a differential evolution. This is also very, very important. It is one of the population based search heuristic algorithm like GA. Now you can see that it can be also used in 5G networks, in radar applications and all, and it can also apply in a reconfigured antenna. And then finally, we can see that how it is. So far you have seen the LMS algorithm and GA. Now we are going for D. So we can see here we are going to place the deep null in unwanted direction, and these weights are going to be adjusted by using the DE, Here we need a highly sophisticated signal processing tool system, and with the help of that we can run our algorithm on highly sophisticated signal processing platform. Then that output is going to control these weights and finally get the desired output. Now it is also a global optimization technique, and it is also comes under heuristic algorithm. The steps involved in DE is like GA. Here also we have initialization, mutation, recombination, and then selection like that. But a slight difference will be there. So once if you understand 4-5 algorithms, then learning a new algorithm is very simple. Initially it takes maybe 4-5 days. Then after that, in one day itself, we can master in one of the algorithms. So by the time you have a good command how this is updating their weights by iteration. Okay, so the terminals are slightly different, but more or less the operations are similar. Not only DE and GE and other algorithms also more or less like this. Slight deviation will be there. Based on that, the terminologies are different. So here initialization, and in the initialization process, we have to initialize the vectors. We are going to call it as a here vectors. There we call it as a population. So here we are going to call it as a your solution possible solution set is called as a target vectors. So with the help of the target vectors X, we are going to get the desired weights. Then mutation is expands the search space. Initial space is limited, and with the help of these target vectors using mutation operation, we are going to explore the search area. So then it is called as a donor vectors. So when you apply the mutation operation, we'll get the new vectors from the target vectors. Those vectors called as a donor vectors V. Then sometimes you are not going to happy. Then we need to recombine these target vectors and donor vectors based on the probability of crossover function, and from that we'll get the trial vectors U. Okay, so when you combine X and V with the help of the crossover probability, the resultant vector is called as a trial vector. So the output of the recombination is a trial vector U. Then once you got it, you have to take the selection process, whether it's good or not, based on the threshold function. And once if it is good, you have to allow to the next iteration. Otherwise, you need to modify. So these are the steps are involved one after the other. Now we have to see that how to mutate the your target vectors and how to generate the donor vector V. So initial target values, you can see that 3, 2, 1, 5, 8, 6, 9 like that. My initial values are defined like this. So based on this, we are doing the operation, and you are not happy with these initial vectors. Once we are not happy, then you have to activate the mutation operation. So with the help of the mutation, the search space is going to be explored. So sometimes if you explain technically like this, the boy will get fed with boring, and he will lose the concentration, and he may not understand the concepts. So whenever that is going to be happening, you need to give one example. What do you mean by these concepts and all? So if you say it expands the search space, means the boy cannot be understand. So they're very simple. I'm giving one example here, relevant example. Assume that you left the pen or book or something on the study room, but you are in some other room, and you need that that pen or pencil or book or whatever maybe that you need that thing. Then what you are going to do, wherever you are there, and you forgot that where you left and where you kept, but you are searching in another room. Then when you search in another room, is meaningless. So you have to take the help of the others. Then what you are going to do, you are going to ask your family members bring the pen or book, something like that, which you want. Then you are going to give the instructions. Sometimes they may not respond, they may not bring to you. So then again you are going to shout. When you are going to shout, immediately they will respond, and they will search in some other room, and again they will report it is not there in that room. Then again you are going to shout. So when you are changing the energy level, the direction of that their movement is changes, and finally they will go to another room, they will search and they will bring. So initially they are in searching in one room based on your instructions, but when you change your voice level, and their search area is going to be changed. So here also you started the solution with available vectors, but you are not happy. Then you need to modify their magnitude and their direction. So here my target vectors are in one particular direction and one particular value, but those are not sufficient to get the results. So I'm going to do the mutation. When I'm doing mutation, these values are going to be modified. So once it is modified means we have the another possible solution candidates. It means that your search area is increased. Earlier you are searched only yourself, and other two members, three members are there. They are searching another room, and again it is not effective. Then again you are changing the instructions. Based on that, they are changing the direction, and you also moved in another room and you are searching, and finally got the pen or pencil, whatever that. So you are changing the direction based on the instructions. Similarly, here also based on the mutation operation, you are changing the magnitude and their vector direction and all. So that the search area is going to be explored. So normally in the investigation, we can see that the police man, they will start at one place, and once they are fed up and they are unable to do that, based on that clues, what are the initial clues are available, and again they will observe very closely. Then from that they will get the clue. From that again they are going to explore the area, and finally they are going to find. So they won't stop where they started at one place. So slowly they are going to expand their search area in a horizontally. So finally they'll reach the goal. So similarly here also we need to explore the area. You have to expand your search area. That is possible with the help of mutation. If you give like this 2-3 examples, the boy will understand. If you simply I modified, the new value came, then they can't understand why it is. The initial values are at one location, and my value is somewhere else. So to go to that, I have to modify this. Then the direction is changed. Like that, it is going. So you have to give the relevant example. Then boy will understand easily, and without much energy, without struggle, the concept will enter into their brains without their permission. So that has to be there. So the teacher has to do without their permission. We have to inject the subject should be penetrated into their brains. So then boy will appreciate. So like that you have to take. Then you can see the one example here. We generated a donor vector. V is equal to. So X is target vectors. Those are initial. XR1, XR2, XR3. These are the initial vectors, or you can call it as a target vectors. Then G stands for generation. Generation 1, 2, like that. So the random vector 1, random vector 2, random vector 3. Initially I have taken 3 random vectors. Then we are doing some difference. We are trying to find the difference operation among these 2 random vectors. Then the difference vector is going to be weighted by mutation factor. So the weighted difference vector, then you can call it as this is the weighted difference vector. When you are taking difference, we'll get the difference vector, and the difference vector is multiplied by f. Then finally you can call it as a weighted difference vector will come. This weighted difference vector is going to be added to initial vector xr1. So finally we'll get the another vector value. So that is the called as a donor vector. So you can see that initial vector 2 and another vector is 1, 2 minus 1, 1, 1 into 0.7, 0.7 plus 3. So 3.7. Initially we have 2, 1, 3 only. So after mutation operation, you are exploring the another value. So that is the meaning of that. So here I have shown the magnitude. Similarly, you can show the vector direction also. So like this, using the mutation, the search area is going to be explored. You can expand the search area. Simply you kept the something in one room and you are searching in another room, is useless. You have to expand your search area, then you will reach the goal. Then you have to take the specifications. One case, number of elements are 20, inter-element spacing is 0.5 lambda, number of iterations 100, initial population is 15, and crossover is 0.8, and constant value 0.6. Here two are there. One is crossover, another is a constant value. This constant value is the mutation factor using to explore the new value, and crossover is to get the recombination. So in the beginning we have seen here. So crossover mutation is done with F, and crossover is done with the help of CR. So the crossover value is 0.8. Then when you apply this DE on this algorithm, here we consider 20 elements in the linear array with nulls at 25 and 45. So exactly at 25 you have a null, and similarly you can notice that at 45 we have another null. So we can place why you are assuming 25 and 45, we are assuming that undesired signals are coming in that direction. So you have to place that. Once if you place that, we are not going to receive the signal, and SNR is going to be improved, or interference is going to be minimized to some extent. Then sometimes I am not interested nulls. For this case, there is no null problem, but we need to control all the side lobes. So then what you are going to do, all the side lobes should be controlled. So in our cast function, you have to consider the side lobes into account. In the previous slide, only nulls is taken into account. That is why I said in the beginning, you have to define the cast function more effectively. So then once you are defined, then you can control. Now here we can see both side lobes as well as the nulls. So side lobe SLL is around 20 dB. Then null is at 65. See, at 65 you have a null. So side lobes are controlled and nulls also controlled. So like this we can do effectively. Then we can take the case study 30, 45, 60. 3 nulls can be placed and all the side lobes can be controlled effectively. Then you have to see the different strategies in a differential evaluation algorithm. If you go through the literature, you will get it around 15-20 strategies. Right now I have listed here 5. So those who are interested, they can go through that literature, they can get the other things. Once we follow this, and understanding the rest of the strategies are very simple. Now you can see that strategy 1, DE/best/1/exponential. Second strategy, DE/rand/1/exponential. So how to understand this is very simple. DE stands for difference evaluation. I am going to take the difference among the targets, vectors, or among the vectors. Simply can call it as a vectors. So to get the new vector, I am going to take the difference among them. So need not be always difference. It can be addition also. In general, it is a difference because it's a differential evaluation. You are going to evaluate. You are going to explore. You are evaluating the new value based on the difference. So the differential evaluation, the evaluation is going to be obtained based on the difference. So we are going to do the difference evaluation and difference among targets. Then which vector you are focused to modify. So I can modify any vector. So the random or a best or best to rand, like that. So in this case, second strategy, the random value. So the random value vector is I would like to modify. So we are going to use the DE. I would like to modify the random. How many times you are going to do? So to modify random, before that I'm going to apply DE one time. So if you want to do the DE operation, I need minimum 2 vectors. So with the help of the 2 vectors, I will get the one time difference. That weighted difference difference vector is going to be added to the random, and this is the selection. So which manner you are going to do, exponential or bin or like that. So finally you can say DE/rand/1/exponential. Similarly, strategy 3. This is the rand to best. Initially is rand. After few iterations, you will get the best. So the random vector is going to be modified to best. Then this is the 2 stands for 2 times difference evaluation is going to take place. So 2 times means I need minimum 4. So 4 vectors I'm going to take. Among them, we are going to apply difference. So vector 1, 2, 3, 4, 5. So vector 1, initial vector 1 is going to be modified with the help of the rest of the 4 vectors. So you apply the difference among these 4 vectors, 2, 3, 4, 5. Then you do some operation and you get the resultant. And that resultant is added to the random. Similarly, here also. So 2 times you are going to apply the difference, and the resultant weight vector is going to be added to the best. So far is the best is available. Similarly, the so far best is going to be modified with 1 time. So once we understand this strategy, please tell me this is for what in the beginning. So anyone can respond? Please respond. Anyone? What is the strategy this one? Anyone? In the chat box or in a voice? Please respond. Anyone? What is the answer in the chat box? What is the strategy, that one? No response. Is it 1, 2, or 3, or DE/rand/1? Anyone can respond? So that way I'm happy you are following. Please respond. Anyone? Quickly. Is that audible? Are you following?
Yes, sir.
Anyone? Please respond. The donor vector B comes
through
under
chat
which
box.
strategy? No, many are not following. I have to repeat again. What is the strategy of this one, this example? Okay, I will explain here now, once again. Answer is there. Anyone is responded? Anyone? Anyone? No response. At least anyone? Are you following or not? Say yes or no in a chat box. Anyone can respond so that I can understand you are active and attentive. Yes, good. Then now I will explain. Good. Fine. Now you can see that this is the rand DE/rand/1/exponential. See, look at here. My random value XR1, this 3 value is going to be modified. I would like to modify this 3. I would like to modify this 3. This is the random value. So how we are going to mutate, how we are going to modify this value? I'm going to use another 2 random vectors. I'm doing some difference among them, and the difference vector is weighted by with F, and the resultant weighted difference vector is added to the XR1. So my XR1 target vector XR1 is modified 3 to 3.7 with the help of F into XR2 minus XR3. So finally, this is comes under DE/rand/1. How many times you are doing difference? 1 time. So this is the rand/1. So I hope that you understand. Okay, fine. So now come to here. So this is the second one, DE/rand/1. But here, which one is you got it? The dark curve. Strategy 5. What is the strategy 5? DE/best/2/exponential. So in this case, this is the good. But don't consider that the rest of things are not useful. Based on the application, you have to find which one is suitable. So don't make it 5 is always the excellent. It decides based on the application. So right now the best/2. So the so far best vector is going to be modified with the help of 2 times difference. So that is the meaning of that. Now you have to make a tabulation. So in the first case, second case, just now you have seen only side lobes, and both 4 cases you have seen, and all these things you have to tabulate: null depth, side lobes, and upward beams, and you can compare. Then similarly, you can see that pencil beam and sector beam, and here we can generate these 2 beams by using one array. So hence it is called as a reconfigurable antenna array. So if you adjust the phase and magnitude simultaneously, you will get the sector beam, and you are concentrated only magnitude and phases remains constant. Then you will get the pencil beam. So with the help of control on the magnitudes and phase, one antenna structure is enough to generate both. So based on the application, you have to control these weights, so that you will get the sector and pencil beam. So pencil beam is used for point-to-point communication, and sector beam is for searching purpose or for wider area coverages. So based on the application, you have to choose. Then similarly, other cases, different cases. Then here you can see that it's a bin selection. The earlier one is exponential. This is the bin selection. So how it is varies and all. Then we need to compare LMS and DE, and how this, and we can see that which one is giving better performance, and you can visualize. You can notice that how it is performing. Then the summary of this is different parameters we have studied, and we have a good control on the radiation pattern. Then you have to go for Taguchi method. So this Taguchi method is based on the orthogonal array. This is purely based on the orthogonal array. Listen carefully, and at the end of the section, if you land a small delta, the purpose of taking lecture online during this bad situation, then purpose of the taking class is meaningful. So if you land a small delta, then I'm really happy. And if you are not land a small delta, is the time waste. Okay. So look at here. Be attentive, be active, because after lunch attending class is not that much easy. But as a teacher, we should have that control, that sleeping mode and all. Okay. So be active, because we are seeing in class also many students will sleep after lunch hour. So immediately after 10-15 minutes, we have to play one relevant joke or a relevant example. Then they are attentive. So now you should be attentive and active. And at the end, if you feel that if you learn small delta, attending this workshop is meaningful, and then we are happy, and organizers and we also are very happy. Now look at here, Taguchi method. This is purely based on the orthogonal array. So once we understand this orthogonal array, and one can play this Taguchi method. So why you want to use the Taguchi method? You may ask, sir, we learned LMS, we learned GE, we learned DE, we seen hybridization, we have seen the steep descent method, Newton's method, other methods and all. That is enough. But see that if you want to do some certain modifications, or you want to find some novelty and all, one has to see the history. And whenever you are getting the novel algorithms or modified algorithms, you should compare with the existing, so that people will appreciate. So now you can see that another Taguchi method, and this method is effectively reduce the number of tests required in a optimization process. So in the optimization process, by using Taguchi method, less number of experiments or a test or run. This is the terminology. Here we are going to call it as a test or a run or experiments. There we are called as a iterations. Okay. There we are called as iterations. Here we are going to call it as a number of tests. Are you got the point? Or strictly speaking, here they are going to call it as a experiment or a run. So to get the optimal results, it takes a very less number of iterations. Strictly speaking, it requires less number of runs. Then this can be used in n number of applications in the mechanical, chemical, and electromagnetics, and so on. Need not be in only engineering sector. In non-engineering sector also can be used effectively. Non-engineering sectors also. Nowadays, people are very, very crazy to use these optimization techniques in to predict the stock market values and all. But you need a lot of data, and you should have the subject of the that stock market. Otherwise, you can't apply simply. But you can do that. You can do that. You can predict with the help of these optimization techniques. Once you have a good background of stock market, then one can predict easily with the help of these techniques. Then you can see that linear array, and this is the array factor in exponential form, e power j psi theta, or kd cos theta plus psi phi n. If you refer any standard textbook, Balanis or Cross and Jordan and Ballman and all, you'll get this equation. Is it clear? Or any standard journals and all, in this direction, if you go through it, you will get the array factor. And if this your array is symmetry, then no need to run 2n. Just half of that number of elements is enough. So here I'm going to run 1 to n. So instead of 2n, I'm going to run 1 to n. So if it is 20 elements, we are going to run 1 to 10, because it is a symmetry, and that is the reason we are going to multiply by 2. So like that you can do. And similarly, this is the in a trigonometry form in the cos domain. One can convert into in this form. Then this is your array factor, and you need to compute this an. What is the magnitude? What is the phase? And you need to compute a distance. These are the things in the last class we have seen. To shape their radiation pattern, we have to select the structure or the geometry or magnitude, a voltage or current, or a phase or a distance. So here an is nothing but the weight. Magnitude can be modified. dn means inter-element spacing can be modified. Then similarly, selection of the antenna structure. Then geometry. Here it is a linear. It need not be linear. Based on the application, you can choose. Then type of. Then one has to concentrate on the fitness function. So here you can see that the first term in this fitness function will give you side lobe control, and the second term will give you what you call null control. So with the help of the this one, null is going to be achieved, and with the help of this integration, we can get the side lobe control. So need not be. We can add other things also. If you want a specific control, bandwidth and other things, then plus another term. So like that. When you add this, then your objective function or cost function is a little bit complex. So based on the application, you have to modify. Then you have to see that Taguchi method. General notation is here EPLT, where E stands for number of experiments or runs or test, and P stands for number of parameters to be optimized. So you have 10 elements antenna. So I need to control the 10 weights and distance or whatever that. Or you want to design the patch antenna, the length, width. Based on that, you want to design the fractal antenna, then the fractal geometry, that index and all these things. We can which parameter you want, that angle. So you can control that with the help of the equations and all. Then L is the number of levels that you can see. So the time being, we assume that L is the number of levels, and T is the strength. So EPLT, this is the another important terms in the Taguchi method, along with the orthogonality. So what do you mean by orthogonality? That we are going to see. So this is the Taguchi method notation, ln of L power k, ln of L power k, where k is the number of factors. How many factors you want to control? Say for example, the array n is equal to 10. So I need to control 10. So A1, A2, A3, A10. Or you got the phases, theta 1, theta 2, theta 2, theta 10. So I want to control 10 phases or currents or whatever, any parameter. It need not be in the antennas. It can be used in any sector also. So these are the parameters, factors to be controlled. Then L is the number of levels per factor. So you are going to feed the current or voltage. So you are going to give 0 volt or 1 volt, or you are going to give 0 milliamperes or 0.5 milliamperes or 0.25 milliamperes. So what is the current levels you are going to give? So what is the levels? Whether it's 2 levels or a 3 level, how many levels are there? So for example, in a binary, if you take it A, B, C, D, then levels are 2, 0 and 1. So like that. So my A is varies either 0 or 1. My B also varies either 0 or 1, like that. So based on the application. So the number of levels means how many levels you are going to accept for each parameter. Then total number of experiments or runs or tests, all are same meaning. So how many runs you need to get the optimal results. These are the terms and meaning of this notation. Now come to the orthogonal array. Now look at this top corner, right corner. Here you can notice 7 columns. 7 columns. If you refer any literature survey, you can get it that. So right now we are considered 7 elements, and each element is going to allow 2 variables. So the levels are 2. Here small l is 2. What are that? 2, 1 and 2. So element 1 can be given 1 or 2. Similarly, element 2 can be fed either 1 or 2. Element 3, like that, and so on. So if you go to the generalized case, assume that I have 2 variables, A, B, and each variable can I feed either 0 or 1. So how many combinations I can get it? Please respond, anyone? Anyone please respond quickly in a chat box so that I'll be happy. Please respond in the chat box. If you have 2 variables and it is going to allow 2 distinguished levels, either 1 or 0, how many combinations I can get it in a digital domain? At least. Are Baba? 4, good. And if it is 3 variables and 2 levels, ABC and 2 levels, then how many? Quickly. Always one person is responding. Satish Kumar responded good. Deepak Kumar is responded good. Right. Now, considered I have 3 variables, 3 levels. 3 variables, 3 levels. How many combinations? 3 variables, 3 levels means 0, 0.5, 1. It's good. Very few are responding quickly. Others quickly. 3 variables, 3 levels. Only one person has responded so far. It's very bad. 8 not 8 is for 2 levels, 3 variables. So 27 is correct. So far 2 members has responded. Others quickly. At least I should get it one more. Anyone? Are Baba, seeing answer also can write. Oh no, 20 never possible. 20 never possible. So Suresh has mentioned is wrong, and Tech Fort 27 is good. So like that, fine. So now I'm going to ask one more. 3 levels and 10 variables. 3 levels, 10 variables. 3 levels, 10 variables. 3 levels, 10 variables. 3 variables, 10 levels. No. Think of that. How you got previously? No, wrong. 3 variables, 3 levels, 0, 0.5, 1. But number of parameters to be controlled, 10. A, B, C, D, E, F, G, like the 10 variables. And each variable is modified by 3. Yeah, 3 power 10. Good. Admin 3 has done excellently. Good. Admin 3 has done excellently. So others are they are not active. I don't know why. Okay, anyhow. So now we can look at here. So if 3 levels and 10 variables, 3 power 10, try to imagine that. Such a big number. And you have to test it. And it's not possible. So, so here just 2 levels and 7 variables. 2 power 7 combinations. So out of 2 power 7, just 8 runs are enough. Look at here. 8. These 8 are not random combinations. This is another important thing. So using Taguchi method, we can get it by 8 experiments. How he got it? Again, I'm going to give the conclusion. He has observed the problem thoroughly, and from that he made it conclusion. So that is why I try to motivate the boy. So you will get it. So now to run this problem, 2 power 7 combinations are required, but simply 8 runs are enough to get the optimal results. So how to design this Taguchi array, orthogonal array? Now look at here. First variable, you can feed 2, either 1 or 2. 1 is repeated 4 times, 2 also repeated 4 times. Then in the second, 1 is repeated 4 times, 2 also repeated 2 times. 4 times. Any column you check it, 1 is repeated 4 times and 2 is repeated 4 times. You can notice that. Any column you pick up and verify number of ones repetition is equal to number of 2's repetition. 1 is repeated 4 times, 2 also repeated 4 times. Now you take any two, look at here, any two columns, 1 2 or 1 3, 1 4, 1 5, 1 6, 1 7 or 4 5, 3 4, any combination. You pick up any two. 1 1 is repeated 2 times, 1 2 repeated 2 times, 2 1 is repeated 2 times, 2 2 is repeated 2 times, and this statement is valid for any two columns. 1 1 repeated 2 times, 1 2 repeated 2 times, 2 1 is repeated 2 times, 2 2 is repeated 2 times for any. That is the reason, you go back, the strength is 2. Here T stands for strength. So in this case, the strength is 2. Need not be always 2. It may be 3, it may be 4, it may be 5, anything. So based on the application, you have to do that. And how you are going to design your algorithm. So your orthogonal, in this case, the strength is 2. If we take any two columns, this is going to be valid. So I hope that you understand E, P, L, T. So just now you have seen E, number of experiments, and P is the number of parameters, L is the levels, and T is the strength. So in this case, strength is 2. Is it possible to strength is 3? You can check it. It has to be valid. Is it 4? Like that you can verify. Then you can make it conclusion. Then now you can see that how it is going to be modified. Level 2. Maximum minus minima by 2 plus minimum. So maximum is 2. Minimum is 1. 2 minus 1 by 2. So plus 1. So 1.5. Initially you are feeding either 1 or 2. Then in the next iteration you got 1.5. Similarly another level. Level 2 1.5. The level difference you can get from here. Maximum minus minimum by number of levels. Here number of levels are 2. 2 plus 1 3. So 2 minus 1 1 by 3. So 0.33. So you can add level 2, just now you got it 1.5 plus or minus 0.3. So 1.6 and so here initially you have 1 and 2 in the first iteration. Then later I can get it if it is 3 levels I can get 3 also. If it is 2 levels I can get any one of these two. Have you got the point? Or so level 2 is 1.5, level 1 is 1.16, level 3 is 1.33. So you can get the 3 levels also. If you want 2, any 2 you can pick up for the next generation. So like that you can explore, you can test your algorithm. So this is the then problem identification. You have to identify the problem clearly. This is very important, and the rest of things are I marked as a one color, that is black test, and the starting one is is somewhat pink color or some light red color. So why I have chosen this? This is the initial step, and if you are going to initialize properly and if you study the problem thoroughly, clearly, and you will get the solution easily. So most of the times the students are not going to, especially BTech fellows, you can see that in the project they will go for directly to the problem and they will attack, and again they have to come back to literature survey and they have to study and all. If they do properly literature survey thoroughly and all, and if they got the problem understanding, and once you understand the problem thoroughly, and how to do the problem is easy and takes less time, and it is comfortable, the journey is very smooth. So you should address to the boy. So if you understand the problem clearly, and identification is very simple. So once the problem identification is over, and if you define properly and clearly, and from that you can get the factors and objectives. Then once if it is coming, then you have to select the OA, suitable OA how to do. Just now I have given how to construct. So the number of ones, the number of levels should be repeated, and the combinations also is repeated, and if any two columns if you take it, the patterns are again is repeated. If you satisfy these three conditions, then orthogonal structure is going to be developed, and based on that you can select it. So you can design the OA, then you can design the experiment, then run it experiment. Once if it is good, and if the results are good, you have to stop the solution. Otherwise ask them to update with the updation of levels. So here you can see that. So you are going to 1 and 2 you are giving. If you are not happy, then my levels are going to be updated with the help of these equations. So similarly here, initially you are defined and you got it, and if it is first iteration itself you got it, and you have to stop. And if you are not happy with that, and you have to ask them to change the levels. So with the help of the update levels, you are going to modify the your coefficients or values. Then again you have to repeat the experiment, and again you can test it cost function. Once we are getting reasonable results, then you have to stop. Now you can go for L27 3 power 16. So here in the beginning you have seen the notation. You have seen the notation ln of L power k. So similarly here L27 3 16. So 3 means stands for levels. How many? 3 levels. What are that? 1 2 3. See, 1 2 3 means 3 distinguished levels I am feeding. The generalized case it is 1 2 3, not 1 volt, 2 volts, 3 volts based on the problem. So for example 1 milliampere, 0 milliampere, then 0.5 milliampere, 0.75 milliampere. These are the 3 levels. So 1 milliampere, 2 milliampere, 3 milliamperes, like that, 3 different values. So we have 3 levels, 1 2 3. So here all ones. So assume that 1 means 1 milliampere. So the entire array is fed with 1 milliampere. Then the second one, you are going to give the another pair, 2 milliamperes, 1 milliampere, 2 milliamperes, 2 2 2, 3 3 3, 1 milliampere, 2 3, like that. So there is a meaning of that. So if it is, say for example 1 means 0, so you are giving 0, and 2 means some another value, 3 means another value, like that you are going to feed. So the different combinations. So you can check it. The one is how many times is repeated. Again 2 is how many times, 3 is how many times. Now look at here. You have 16 elements. You need to control 16 parameters in your array. My antenna structure have 16 elements, and I need to adjust their phases or magnitude or something, either distance or whatever may be that. So I need to adjust. So when you want to adjust the magnitudes, and with the 3 levels, 3 power 16 combinations will come. So try to use the calculator. It is not possible by just multiplication on the paper. So when you use the calculator 3 power 16, then it will go to the hundreds of crores operations, hundreds of crores operations. Then to get the results, you need to test it. You can't stop in the middle. Even if you are getting, we can't be happy, because unless if you complete all the combinations, we don't know whether the best next iteration will give the best results or not. So we have to wait for until all combinations has to be verified. Is it clear? So if you want to do test it hundreds of lakhs of combinations, after for 10 iterations, the human being will lose the concentration. Because the repetition operation, adding, multiplication, subtraction, then division based on the operation. After 4 or 5 iterations, we lose the control on that. We lose the control. So what you are doing manually, one iteration, the same iteration, the process is going to be repeated n number of times by your algorithm. That's the thing. So human being is not possible to do all the possibilities to be verified. So you will verify 2 or 3. After 2 or 3, you will be fed up. You lose the interest. You lose the concentration. and sometimes you'll get the headache also, and you finally will make it. It is a tough subject, it is a boring subject. What is use of that? I like that you are away from the subject. So in that case, one has to use the some toolbox. In that toolbox, what you did by one iteration, the same iteration is going to be developed in the algorithm form, and your algorithm is going to repeat. That poor fellow, because it doesn't have the sense feeling and all, that fellow will do. Once this energy is there in the system, then that fellow will run. That's the core point. But a human being is not like that. After a few seconds, after some time, he is going to be exhausted energy. So it is very difficult to do that. So if you feed this entire concept on the DSP platform, then that system will do for you. Are you got the point, Anna? Now you can check it. How many times one is repeated? Anyone can answer in the chat box, Kelly? In a 3 power 16, in a 27 iterations, 3 levels are there. 3 levels are there. 1, 2, 3. How many times one is repeated in a 27? How many times? How many times one is repeated in a 27 experiments? Anyone, quickly? How many times one is repeated in a 27 experiment when 3 levels are existing? I'm repeating. Yeah. So that's all. 9. Good. So we'll go to quickly. One has responded. Nice. So when you go further, similarly, 2 is repeated 9 times, 3 is also repeated 9 times. And you can check it, any 2 columns or any 3 columns, any 4 columns, and find out the strength. So based on that, you can decide whether strength is 2 or 3 and all. So how many times 1 is repeated, 2 is repeated, 3 1 and all these things. So here orthogonal property is satisfied, and based on that we got it 27. So we can based on the rules and regulations, one can develop the orthogonality. If you are unable to do that, go to the literature, then you can get the readily this orthogonal matrix are available. With that you can do that. Then you can see that is a 10 element linear array, and side lobes are controlled from 0 to 82 and from 98 to 180, and all the side lobes are controlled here. No, okay, all side lobes are controlled. See, all the side lobes are much below 40. Much below 40. Generally, if you refer to any standard textbook, in the standard, when you are not going to control the side lobes, it is 13 dB. Without controlling the side lobes, using the dot shapes and all these things, without controlling side lobe. Using there also can do that. So if you use the array factor simply without controlling the side lobes, then you'll get the 13 dB. But using this algorithm, we can have around 40 dB. Then convergence plot. No need to explain already. We discussed what is the significance of the convergence plot. Then weight updation. So based on the application, it will come. Then this is a different case. So 32 elements. Then again convergence plot. Again different elements, how it is converging. Then we can tabulate all the values. So the reduction is 57. Then another important is quiescent array factor. This is another pattern. So it's going to be used frequently in radar applications and in mobile communication. So why this is quiescent shape is required? And now if you look at the trigonometry function of the quiescent function, it is like some hyperbola shape. Then that type of shape is required in our field. Why means if you take the in the class, when you are radiating the energy, when you are taking the class, the first person is audible, and the last fellow is unable to hear, unable to hear properly because of energy levels. Then that fellow will come. Sir, we are unable to hear. Then immediately we are going to increase their energy level. Then the boy will be comfortable. But in the class it is okay. But when you go for the auditorium, and what you are going to do, if you take the same thing class in the auditorium, then we can't get the energy at all. We can't get the energy because the first bench itself far away from the diodes. So at least 10-15 feet. Then the signal will be completely zero. Then we have to use some electronic mechanism, electronic system, public addressing system. With the help of that speakers and all, mics, and with that we can get the energy level throughout the floor is constant, and people are going to be comfortable. Are you got the point? Then if you want to communicate the signal for a long distance, one has to use the wireless or wired mechanism and all. So when you are using the wireless communication, see that the person who is very closer to the tower, you will get the more energy, and the person is away from the tower is getting less energy. Since the signal is attenuated, once the signal is propagating, it will be attenuated. We know that. That I'm not going to touch whether it is inversely proportional or all these things. I'm not going to touch right now. So as the signal is propagating in the free space, signal is attenuated. Your electromagnetic signal strength is decreasing. So at the boundary side of the coverage area, the person is getting less energy, and the person is closer to the base station, you will get the good quality of the signal. But both are paying the same amount for the connection. But this fellow will get more energy, that fellow will get less energy. And this fellow battery life is going to be increased, and that fellow battery is going to be died quickly, or he has to recharge quickly, because most of the energy is for searching purpose only. His mobile is trying to search the signal. So for that itself, the energy is going to be wasted. And he need more large signal, strong signal. He need very little signal is enough. So these are the differences are there. Because of you are not generating based on the demand of the energy level. So when you radiate uniformly due to the distance, it is decaying. It is decaying. But this problem demands the person who is very close to that is demands less power, and the person is away from that demands more power. Even in the class also, the person is very close to the dais, he will request less power. The person is away from the dais demands more power. But we can't give that type of energy. It is very difficult. It is not possible for a human being. But when you are using the some electronic mechanism system, it is possible if you do properly, if you are going to adjust your radiation pattern. If you are giving such examples, if the boy is still unable to understand, then you have to give a live example, which is seen by him in his colony. A water power supply. So water will come from the overhead tank, and the few colonies will get more pressure, and few colonies will get less pressure. Why means some colonies are very close to the overhead tank, they'll get the good pressure, and some colonies are away from that and they can't get the good pressure, and to get water they have to struggle the things because they are not getting a good pressure. Then what they will do, that municipal corporation, to get these fellows also, they are simply giving 2 hours, 3 hours like that. But with 1 hour itself, some colonies are getting overflow, and even at 1 hour, some colonies are there are not at all getting the water. So if you are giving more time, and somewhere else water is wasted because of these fellows. And they need to, if they studied the problem thoroughly, they should have good controlling mechanism. So when they are releasing the walls, nearby colonies, when they are released, they have to stop the far end colonies. And when they are trying to release to the remote areas, and the nearby colonies, walls should be closed, so that the pressure is going to be increased. But they are not doing. So they have to operate 2 walls, one wall at near and one wall at a far end. So what happened? They are not going to. They are going to open both. So pressure will be less. One place it is more, one place is less. So if they are going to handle properly these walls systematically, and people will get a good amount of water in a specified time. So instead of that, they are giving the simply, and most of the water is going to be wasted. So they are not studied the problem thoroughly. That is the reason in the beginning I said, if you study the problem thoroughly, and solution will come. once the solution will come, you have to execute that. So these are the things. If you educate the boy will understand the problem and they'll get the solution easily. So here we need to do that. The person very close to that demands less power. So I need a non-uniform profile with respect to the distance. So that has to be designed. So now you can see that we have to develop the question pattern here, and this is our evolutionary algorithm, and you can see that. Then your fitness function is quite different, because your goal is different, your objectives are different compared to side lobes and nulls and all, because my pattern is completely different. So based on that, we have to define the cost function. So this is one important thing. So that is why once if you understand the problem, define the cost function is easy. So if you motivate like this, if you give the relevant examples, then boy will understand, oh, the problem to problem is like this. We have to analyze, we have to understand the problem thoroughly, then we'll get the solution, and like that. So then number of elements are 24, then inter-element spacing is 0.5 lambda, and Taguchi parameters 27, 12, 3, 2, 27 elements you need to control. And what is this? This is the, what do you call, anyone? This is the 27 is the experiments. Sorry, this is the 27 is experiments, and 12 is parameters need to be controlled. But is it 24? Why I 12 means because symmetry. So 12 parameters I'm going to control, need not be 24. So 3 is levels and 2 is the strength. So like that you can do. And so like you can have this and you can do that. And so finally convergence is good and is quickly converged. Then you can see that this is the profile. This is the profile. Now you can see that this is the profile. So here more energy is required at 90 degrees, more energy at 130 is less energy, and in between it is a cosecant fashion, and it is called the cosecant array factor. Are you got the point or not? It's not like a pencil beam or a sector beam like that, or omnidirectional, or it is quite different. It is quite different. So the shape, the profile of in the main beam, if you see that it is a cosecant shape. So this angle demands more power, and this angle is demands less power. So this angle is means from the elevation angle. So more angle means this person is closer to the base station, and this angle is less. Are you got the point or not? So is the far away. So elevation angle is less, because the person is very closer to the earth station, elevation angle is more, and the person is away from the base station, elevation angle is less. That is why you can see that at 90 degrees more power is demanded, and the person is very closer to that means elevation angle is more, so he is required less power. So that is the reason it is a cosecant shape. Then these are the parameters to be controlled, and this is the tabulation and convergence plot, and we can make a conclusion like this. You can make a conclusions. So I hope that you understand the Taguchi. Similarly, hybridization is there. Right now it is 4 o'clock. Almost we are reached the end of the section, today's section. Whenever the time permits, then we'll see that continuation of this. These are the other concepts. These things we'll see. DOA based algorithms, the other algorithms also we can see. Okay, DOA and teacher learning based techniques, then Rao's algorithm and other algorithms we can explore. We can see that. So whenever the time permits, we'll see from the continuation of this class. The rest of the algorithms can be seen. So any doubts till now?
Thank you, sir.
So please ask
Thank
me.
you, sir.
So now
Participants, can I ask you a question?
Please chart, or you can ask directly. It's up to you. In chat box, you type it, then we'll see.
Any queries?
Please ask if you have any doubts. I will answer. No questions? At least one? No. So
Sir, I have a
otherwise,
doubt,
you say
sir.
yes or no. Any questions?
Sir?
Is it audible?
Yes, sir. I have a doubt, sir.
No response, no response. Any questions from the participants? No doubts. Good. Others? Good, good. Right. Right. So, okay, we'll see that whenever the opportunities comes again, we'll discuss
Sir,
the. Yes, yes, madam. Tell me.
I have a doubt, sir.
Ah,
How can I use the Tahuchi algorithm in my fractal design, sir?
how can you use? Repeat the question.
I want to use the Tahuchi algorithm in fractal antenna design, sir.
Yeah. You can do that. See that when you are using the not only in the fractals or anything, you need to do that. What is the meaning of the fractal? To increase the electrical length.
Yes, sir.
So generally, it is a square block or a rectangular block, and the circumference is 4L. Is it correct? If L is 10, then you got 10 into 4, 40 centimeters. If it is centimeters, if it is mm, 40 mm. So 4 into L. Then I want to increase my circumference. Then you are going to take the, you are going to remove the some copper areas in the boundaries. So when you remove the copper areas, we will get the what do you call the circumference is now is going to be increases. The length of the boundary is going to be increases. Earlier it is 4 into L only, where L is 10. So 4 into 10, 40. When you are going to do first iteration, your circumference length is going to be increases tremendously. Then to get your particular problem, your particular problem, normally students will do 4-5 iterations. First iteration, second iteration, third iteration. They will do repetition. They will satisfy the symmetry or anti-symmetry trial and error method. First iteration, they got it means good. Second iteration, then third iteration, like that they will do. At one moment they will get, or reasonably they will get, and with that they will compare and they will quote it. But after 4-5 iterations, assume that you are done 4-5 times, you are not getting. Then what you have to do? You have to do again. Finally, you will be fed up. So how many times you have to do? Trial and error method is not good. So for that, what again? You are going to the literature survey and you are referring some journals, and in that they will tell for so and so frequency, these are the things I use, and again you are going to take and you are doing some modifications, and then you are going to get the results. But when you start by your own and you want to get for a particular resonant frequency for a particular fractal area, you have to develop the equations first. What should be the angle? What should be the length? What should be the edge? You develop the equations, and these equations you take it into in the cost function, and if you increase the depth 2 centimeters, then my what do you call my what do you call the resonant frequency is moving either right side or left side from the desired frequency. You have to write the array factor in that when I change this distance, how it is shifted. So you have to write a program with the Taguchi, and in that you have to take this cost function into account, and you should have interlink between geometry parameters and array factor and your iteration steps. If you coordinate these 3 steps in a systematically and properly, and what you are doing in a trial and error method, the same thing your algorithm will do. Then you'll get the results. And say for example, if you go to now you are doing manually with using CST or Ansoft or IE3D, CST, any software, and you are going there, you are going to take the vertical and horizontal angle you are going to give, and you will get one patch or one first iteration fractal antenna, and you are going to run it, and you will get the radiation pattern in a vertical plane or horizontal plane, whatever that. You are not happy, then again you are changing, like that you are doing. But for that no need. If you go to some toolboxes, there if you feed theta value, distance and all, it will give you what is the optimum value for that. How that fellow is done? In background, this optimization technique is there. In the background, the optimization, when you give that, if you take that simple example, say for example, I want to design a patch antenna for a mobile application or Wi-Fi application at 2 gigahertz, then what should be the my L and width or L and B? So if you want to do that, you are a elementary level and you don't know, but you are asked to do that. Then what you are going to do? You are going to enter a resonant frequency 1 gigahertz. The bandwidth is this much, upper beamwidth this much, 3 dB, 10 dB, like that you are giving in that. And if you press that, after 10 minutes or 20 minutes, based on that software, it will give you, take the length is 2 centimeters, this is 4 centimeters, and you are going to take 2 and 5, then you got the results. You are not to use the equations and all. In the background, when you give that, these equations is placed, and according that array factor is going to be verified. Once the array factor is obtained, it will be stopped. I hope that you understand. So
Okay,
it is possible, we can do, but one has to have good command on equations. You have to develop the mathematical expressions for your fractal antenna.
awesome.
Then it is possible.
Okay, okay, sir.
Yeah,
Thank you.
it's good.
Thank you
Nice
so much.
question. Anyone?
Any other questions? Shall I conclude, sir?
Yeah, it's good. So now I'm concluding. Thank you, one and all, once again. So shall I log out?
No, sir. I shall conclude, sir, the session, sir, and then you can leave, sir.
Yeah, good. Right.
Please wait for 2 minutes, sir.
Right.
Thank
Madam.
you. Thank you for spending your valuable time to share your knowledge, sir. The participants participants would definitely gain enough knowledge in the same topic, sir. Because you have explained the optimization concept starting from the basic antenna radiation pattern for different applications, the beamforming basics, the significance of optimization techniques in beamforming, algorithms like LMS algorithm, genetic algorithm, and then differential evaluation algorithm, Taguchi method, and these are all very useful, sir. The real-time examples like classroom example you have given in the session, and your interaction with the participants made all of us to alive throughout the session, sir. It would be
Good,
very
madam.
it would be very useful for those who are doing research in that field, sir. Thank you,
Okay.
sir. Thank you so
Thank you,
much.
madam. Thank you. Thank you. Thank you, one and all. Right. Thank you.
Thank you, sir. Thank you, sir.
Right, madam. Right, madam. Thank you.